Yesterday, we talked about declarative pipelines by Databricks. The declarative pipelines were launched as the Delta Live Tables product last April. And while yesterday we focused on very database aspects and typical database research related optimizations, today we're going to see the interesting interplays with software engineering, with systems and data quality. So,
wake up.
All right. Now that you all wake up, a quick repeat of what is the opportunity and the problem of data engineering. By this point, every organization knows that clean, comprehensive data are important in achieving business outcomes. And by this point, also most organizations know that there is a lot of messiness in data engineering. They have struggled with a lot of tools that I'm not going to go over. So they want something that is simple, reliant, and performant. And how does Databricks help in this picture? First, the foundation is the lakehouse that actually was covered in CIDR last year by Matej Zakaria's keynote. The lakehouse is based on the Delta Lake, an open format, which actually there is a lot of activity on this in Amsterdam, a bunch of people who are in the audience now. And the Delta Lake format allows you to bring all your data in the lake and achieve at the same time reliability and query performance. On top of it, there is the Unity catalog that provides governance on top of your data assets. And then there is the multiple purpose-built solutions for data warehousing, for data science and ML, and there is a large partner ecosystem that is also building on top of it. Actually, some of it was presented inside there as well. So now going to the data engineering part, the latest approach that we recommend is the declarative pipelines and with DLT. And a repeat from yesterday, a declarative pipeline is conceptually a DAG where the sources are basically ingestion tables, technically streaming tables that receive the ingested data. And the inner nodes are materialized views that transform the raw data into enriched data, aggregated data, clean data. Okay. The key differentiators here are basically coming if you take a step besides a conventional take on materialized views and you start thinking about databases meet software engineering meet systems. Okay, so starting with the databases part, going beyond materialized views, something that matters a lot is ingestion, which is also accomplished in SQL in our declarative pipelines of Delta Live Tables. The ingestion goal is the following. The typical organization uses a bunch of staging systems. A very typical staging system is basically the cloud itself. You know, people put files from some operational database into S3 in order to be picked up for analytics. This is where ingestion is coming in. The autoloader, which is basically invoked by a table function in here, is the one responsible for incrementally and efficiently capturing the new files that appear at every time in some path or paths in the cloud storage. Out of these paths, which can be JSON, CSV, Avro, Parquet, it will infer a schema as it incrementally picks more files during subsequent invocations, it will evolve as well the schema. And in the case where there is no schema to be inferred, no structured schema to be inferred, there is always a rescue data column, which is basically keeping the data in a schemaless and structured fashion as string. The ingestion is a bit more complex, more often than not, than simply saying I'm picking files from the staging and I'm appending them into the ingested table, because very often these files have some characteristic that is indicating whether the incoming row corresponds to an insert or a delete or an update. Okay, and this aspect is achieved by a declarative command that is called apply changes into. It looks very much like the merge into that you know from pretty much any warehousing that allows you to have a source and merge it into a target, with the caveat that in the ingestion case, the apply changes into has also to take care of the possibility of out of order events. For example, you may get the deletion of something before even the insertion of that something. Okay. And there is also other aspects, notably partial updates. Very often people are basically sending you only part of the new record, and it is expected that you know how to fuse it with the old part that is already in the database. And very often people want to distinguish whether the evolution of the ingested table is happening as a conventional take, where when you get the delete, you truly delete, and when you get an update, you truly update, or whether it's happening as what it is called CICD2, slowly changing dimension of type 2, where basically they want temporal table features on the treatment of the incoming data. That is basically the delete is not really deleting, but it's moving to the next version. Now, data engineers don't just code, they collaborate, they version, they test, they validate, they monitor, right? And you cannot do this simply with create materialize view and drop materialize view. So for the data quality part, you can attach to tables what we call expectations. Expectations are basically constraints. Actually, they're called constraints here. And when they are violated, you can specify a policy of what should happen to them. Should they just drop the whole pipeline, stop the whole pipeline? Should they just drop the record? Should you just log it and keep going? There is an interesting problem here of how to actually evaluate these constraints efficiently without slowing down so much the normal process. Now, the violations that you get out of the expectations that have been violated are going into a log, and this event log is actually, besides the violations, it also gives you information about the whole operation of the pipeline. What was activated, what table was created from data of what other table, and so on. Okay. Actually, people have even built DLT pipelines on top of the event log just to understand better what they are doing. Another aspect that matters a lot is the CICD, continuous integration, continuous deployment aspects of the pipelines. So you write this script, it has multiple materialized views and so on. You test it, here is 5 errors. Oh, I had to put an extra condition in the where of these materialized views. So developers, data engineers, they don't want to go into, I dropped this materialized view, I keep the rest, I'm restarting this materialized view, and then I'm throwing again refreshes. No, rather they just have one text that is basically specifying the whole pipeline. You go, you change here something, you run it again. It's not a create materialized view, it's a create or refresh materialized view. That is basically, if the materialized view has not changed, it will be incrementally maintained. If it has changed, then it will be recomputed. We want to become smarter about this in the future, as we also see a lot of cases of piecemeal evolution from the old materialized view to the new materialized view. If you fancy answering queries using this kind of problems, talk to me afterwards. Another aspect that matters a lot, actually, let me skip here some slides about the usability. There's a very nice UI by which you can automate the whole operations. But the whole thing about operations basically boils down to nobody wanting to have a pager all the time and noticing when there is over-provisioning, under-provisioning problems, and so on, when the pipeline has failed and all of this. So for starters, when a pipeline is failing and it is in production mode, it will automatically retry. Interestingly, on test mode, it will not automatically retry, because when you're testing, that's exactly what you want to know, actually, that things are failing. And another very interesting aspect of the automated operations is the enhanced auto-scaling. Right? You know that a typical problem in the cloud is what should I provision? What kind of cluster should I provision? And there's usually an unfortunate human being that has to deal with this question, or an unfortunate company that basically doesn't need so much this human being because it over-provisions and pays much more than it should. And the solution in here has been enhanced auto-scaling. Basically, a mechanism that is monitoring the backlog, monitors the utilization, and has basically the feedback loop and the learning loop, so that when it notices small backlogs or no backlogs, then it lowers the provisioning and vice versa. So this way, you don't need someone with a pager to dealing with these things. It happens automatically. So in short, I hope I gave you a taste of how there are some very interesting intersections, and I gave you a bunch of them, with the software engineering practices that people are using. So it's basically software engineering practices meet streaming tables and materialized views, and with system aspects aiming towards simplicity. And that completes basically the aspects that we discussed yesterday, which were more around conventional database optimizations. Thank you.